Yeah, because they walk in and they're like, then I got this and I put it in groups and then I got really tired of putting it in groups. All right, what you got from the book? Or the book? The book. Where? No, we did not. Okay, so y'all got 49 and 50. So it's, all right, let's look at 44. It says which could be true. Thank you, Madison. I'm just writing away, carrying right on. If the second derivative of g is 1 over t to the 3/4. So this is one of those multiple choice questions that you kind of hate because you have to work out all of the choices because you don't know how to go backwards yet. So I'm going to start with A, and I'm just going to take the derivative of the derivative and see if that's what I get. So A. Derivative is 4 times the 4th root of t minus 4. That's the way I would work it because you hadn't really, it's setting us up for antiderivatives real soon is what it's doing. This is really to the 1/4, right? So I get t to the negative 3/4, and then there's nothing to chain, yes? So look, A would work.
I didn't realize there was a lot more.
What do you mean a lot more than one? There's 2 right.
Well,
so B says, could the third derivative be negative 4 over the 4th root of t? Well, so I take the second derivative and I derive it again. So this is really t negative 3/4. Yes? Right. So the third derivative, okay, negative 3/4 t to the negative, and I need to subtract another 4 over 4, so negative 7 over 4. So that one does not work. And then C, could g of t be t minus 7 plus 16 over 5, t to the 5/4. Oh my gosh, gross. All right, well, first derivative, we'll have to do it twice, would be 1 plus, now I'm going to multiply 5 over 4 times 16 over 5, t, subtract 1 1/4, so this would give me 1 plus 4t to the 1/4. And the second derivative of that would be t to the negative 3/4. Is that what I started with? Yes. So that one would work. So C would work also. Y'all see what I'm doing? I'm looking back. See, written in black at the top is what they gave me, right? And so each of these, I'm going from what they gave me to see if I can get back to the second derivative and it's the same as what they gave me. Because it says, which of the following could be true if the second derivative is this? Because if that's a third derivative, right, if I take the second derivative and I derive it, that doesn't give me that. So that couldn't be right. And then the last one, could the first derivative be 1/4 t to the 1/4? Well, if I take the derivative of that, I get a 4th times a 4th, which is a 16th t to the negative 3/4, which is not what I started with, so that would not work. No.
I didn't.
Yes, sir, maybe so. Sorry. Okay. No, for that one, there wasn't an indication that would let you know there's only one. On the exam, there's only one answer. You know what I'm saying? So you don't have to worry about two. I'd have probably got to A right there and stopped because I would have thought the same. All right, what else? What? 50? 5? 55? Yes. The problem of Descartes. Find the slope of the problem of Descartes. They give these big fancy names to these equations, but it says find the slope at 4, 2, and then also find the slope at 2, 4. Well, we know slope is what? Derivative. So I am going to find the derivative here. I'm going to find dy dx. So I get 3x squared plus 3y squared dy dx minus, and now I got to do product, yes? Derivative of the first times the second plus, and I got to put this in parentheses here because I'm subtracting all of this. So be careful, watch those signs. Plus the first times derivative of the second, which would just be dy dx. And it still equals 0 because derivative of 0 is 0. Y'all with me? I need all the dy dx's on one side and everything else off on the other. So I got 3y squared dy dx minus, because that negative is going to distribute through, 9x dy dx. I'm going to go ahead and move these over. Will that confuse anybody if I do that all at one time? Plus 9y minus 3. Factor out the dy dx. If I'm going too fast, tell me. It is hot in here. You're right. You're welcome. Divide. You could if you wanted to. I don't want to. I'm not going to just because I'm going to go ahead and plug in now. I'm going to plug in 4, 2, and then I'm going to plug in 2, 4. But if you want to, definitely make your numbers easier to work with. It said find the slope at 4, 2, and 2, 4. Slope at 4, 2 would be 9 times 2 minus 3 times 4 squared over 3 times 2 squared minus 9 times 4. 18 minus 16 times 3. 32, what? 32 plus 16, 48, is that right? 12 minus 36. So that would be negative 30 over negative, what? 4? So y'all got? Oh, you're right. Sorry. Bless you. I don't know. I hope so because that's what I got. 504. And then it said the slope at 2, 4. 9 times 4 minus 3 times 2 squared over 3 times 4 squared minus 9 times 2. So just flip them over. Make sense? Boy, it's like talking to zombies. These zombies moan. They don't do anything. At what point other than the origin does the folium, is it folium? Does the folium have a horizontal tangent? That's what we just talked about. Uh-oh. No, it's not. I was like, I got this kid in my calculus class that goes to the care swing every Wednesday. It sings for the. That's not weird. I know. You restored some of my faith in humanity. All right, let's see where we have horizontal tangents. We've got this nice dy dx. This is kind of like the FRQ that we did yesterday. Where are tangents horizontal? Tangents are horizontal where the derivative is 0. Where is a fraction 0? Only where the top is 0. So where is 9y minus 3x squared equal to 0? And so remember, I need to solve this for one of the variables, and then I'll use that and plug back in to find the other one, the other coordinate, right? Does that make sense? Okay, so I'm going to solve this for one of the variables, right? In other words, probably y, because it's just the top, that's right. So if 9y equals 3x squared, divide it by 9, I get x squared over 3, right? Or 1/3 x squared, whichever you want to do it. That's just the y, and this is where it's happening. So to find the x value of where this is happening, I need to go back and plug this in that original equation. X to the third plus, and then I've got y cubed, so I'm going to make it x squared over 3 cubed. Is this a calculator problem? Minus 9x times x squared over 3. You said yeah or no? But their answers are given very exact. X cubed plus x to the 6th over what's 3 cubed? 81. I was taking it to the 4th. Minus, all right, that's just going to be 3 x cubed. So I have negative 2x cubed plus, I'm going to make this like this so you can see what's going on. Factor out an x cubed. It said everywhere except the origin. This is why they had an exact answer. All right, so that goes to 0, but it's not going to count because they said that no origin. So I'm just going to look at this piece. What's wrong? Did I lose y'all? Are y'all laughing about something else? Oh. 1 over 27x cubed equals 2. Multiply by 27, so x cubed is 50. Oh. Cube root. Luckily, it's an odd root, so it's only got 1. Do y'all have to memorize those books or something? Y'all are like practicing these little picture books over there, like this is fixing to be. X is the cube root of 54, which means y is going to be that point. Y is x squared over 3. Yeah. I was finding where the derivative is equal to 0, so where the top of the fraction equals 0. Corresponding point. Okay, now listen, let me say this. listen, if this was a because this is a very probable question for the AP exam, but I would say that this amount of work bogs you down. I would say that this is probably a question that you would see on the calculator portion of an FRQ, and if it was, remember how we talked about using that calculator to solve for us and stuff? You don't remember how to do that? How to use the calculator to solve for you? So if you have any equation equaling to 0, if you have any equation at all and you make it equal 0, it doesn't matter what that equation is, you can graph it, and wherever it crosses the x-axis is your answer. So if I stopped right here, right, or actually, yeah, if I stopped, what did I want? I wanted the top. I could have solved this one for y, so I could have gone here and found where it crossed the x-axis. You'd rather do all the work? No, this would be an FRQ. This would definitely be an FRQ. Huh? No, why? Well, we must not have got there yet. There's 2 calculators. That's a non-calculator. What the heck? All right, let's move on to part C, the coordinates where it has a vertical tangent. This is same song and dance. It's just the bottom to 0 instead of the top, right? Because vertical tangents are where the slope is undefined. So those are the 2 big concepts here. This was horizontal tangent. So now, after the FRQ, yeah, it's better after the FRQ. Okay. All right, what else on your homework? 56. 56, the line that is normal to the curve, there's my clue here is the normal part. X squared plus 2xy minus 3y squared equals 0. The line that is normal to the curve intersects the curve at what other point? All right, so let's see. Let's do. No, you won't be able to graph this. Let's do derivative first. Let's find slope. We know we got to do that. Derivative of the first times the second plus the first times derivative of the second minus 6y dy dx. All right, I'm going to skip a few steps here because I assume y'all can do this like pros by now. I'm just finding dy dx. I'll even take a 2 out like Robert likes to do. All right, so there's my slope, right? This is slope of the tan line. So if you want a slope of the normal line, because this says find the normals to the curve, the line that is normal to the curve at 1, 1 intersects the curve at what other point? So I need to know the slope of that right now, right? Go with me? All right, flip it in what? And change the sign. So slope of the normal line is going to be, I'm just going to do this and see. I just flipped and I put a negative outside. Okay, so the line that is normal to the curve at 1, 1. So my slope of the normal at 1, 1 is going to be negative 1 minus 3 over negative 1 minus 1. Negative 2, negative 2, but everything's negative, so the slope is 1, right? Yeah, I was. So the equation of the normal line, all right, so we got to think about this for just a second. The equation of the normal line would be y minus 1 equals slope times x minus 1. And by we got to think about this, I got to think about this too. I've got an equation for a normal line. Normal line means that it's perpendicular to the tangent line, right? Tangent line only intersects one time. Is it possible for a normal line to intersect the graph more than one time? Yes. And this is saying it does intersect the graph more than one time. Where else does it intersect? So I would say, well, you tell me how you think it's on it. Plug it into what? You're actually there. If this is the line, where in my original equation does this happen? So I'm going to plug negative x plus 2 in for every y in that equation to see where that is occurring. If you think about it, you can figure this out. These make you, that's the great thing about the application part, though. They really make you think deep about it. Okay, let's plug it in and see what happens, because I want to see what happens now. X squared plus 2x, it's not y anymore, it's negative x plus 2. Minus 3y squared, it's not y anymore, it's x plus 2. Equals 0. We should be able to find an x value now. Yes? Say yes, if we can. Yes. Thank you. Minus 2x squared plus 4x plus 3x. Oh, nope, Stacy. X squared minus 4x plus 4. I'm just going to keep trudging through this. This would be, if this were the FRQ, this would be a part B, and it would probably be like 14. Probably almost half of your. When they give you one that takes a long time, your first ones would probably be super duper easy. Find but do not solve the equation for blah or whatever. And then they'd get to part C or D and they'd throw something like this on there and it'd be worth the bulk of the point. But, right, more than likely. No, then you could still have the potential. They would look back at that. Oh, I do. If you have to use it, I'll go back and say, based on your A, this is what. Most of the time, though, y'all don't get C, you didn't get A. Most of the time, they go hand in hand. This looks like a factoring problem. And there should be two places, right? We know one place is the point of tangency, but then it's telling me that there's another one. So one of these x's, does it tell me where? X minus 3, x minus 1. So at x equals 3 and x equals 1. Yes? We already knew this. That's the one we knew, right? That was the slope. We had one some. Oh, because they told me 1, 1. Yeah, they gave it to me. They forgot to tell you. So this is the other point that I'm looking for, is that 3. That's not the whole point. That's just the x part. But lucky for me, I have this nice little equation right here that tells me what y is. So y is negative x plus 2. So the normal line intersects the graph at 3, negative 1, and 1, 1. Please, for the love of everything, tell me that's what they got. Yes, they did. 3, -1. Yes, they did. Whenever I found this y equation here, I found the slope of the normal line and I wrote an equation for the normal line, right? So then I've got all this going on, and what I did was I found an equation for this line going through like that. And I said, they gave me this point, 1, 1. I want to know what this point is. So if I've got the equation for this line is just y equals whatever, right? If I take that whatever and I plug into this equation, it'll tell me the x that goes with it. Yeah. I think you're doing this, and it's really like whatever. What else on your homework? Somebody said 53. Yeah, they'll be kind of straightforward. You might have one that's kind of wordy. They're all multiple choice. I think there's 6 altogether questions. But no, like 5 and 1 other problem. 6 altogether, I think. Yeah, it was. It was a word problem. I added it. Probably. All right, give me, what'd y'all say? 50 what? 50. We just did the folium. All right, 53, because I've heard that several times. Velocity is 8 times the square root of s minus t plus 1 feet per second. At the instant t, the body has fallen s feet from its starting point. Show that the body's acceleration is 32 feet per second. You want to do it right now? It won't take long to take it. You need probably 30 minutes. We're going to do a lesson after we do it anyway. Tomorrow. Yeah, but I'll record it. Because that's all we need is just a little bit of time on that. It doesn't pop up a whole lot. Just give us, it'll be out of the way. Then we can come back from fall break and do the good stuff. Okay. The velocity of a falling body has fallen s feet from its starting point. So what does that tell me? That tells me that this is position. So I'm going to have to think about that chain rule for this one, is what's happening. So if I want to show that acceleration is 32 feet per second, let's think through this. The derivative of velocity with respect to time is going to be, I'm going to make this, okay, 4, because 1/2 times 8, s minus t. Now remember, s is a function here, okay? I don't know what it is, but it's a whole stinking equation. I'm not given that, okay? And I say that because whenever I chain this, what's the derivative of s? Well, I don't know because I don't know s. It's not just a single value. So I'm going to have to do ds dt minus 1. Right. Let's say I told you that S of t was 5t plus 3. If that was plugged in there, wouldn't you do the derivative of that? So if I wrote it like that, would that make more sense? Because do I know the position function? No.
But why did you have that?
But time is just a specific value, right? I just plug one value in there. It's not a function. But position is a function, right? I'll have some equation for it, right? All right, now here's where you really have to think about this. Does everybody understand where this came from? Okay. What's another way I can say the derivative of position? Velocity. Wasn't I given velocity? In the very beginning, right? This is velocity. That is the derivative of, so plug it in. For s minus t to the negative 1/2, right? If you take the derivative of position, if this is my position and I take the derivative of it, what have I found? Velocity. What was I given to start with? So if you agree that this is interchangeable, then I'm just going to plug it in there. Y'all are going to hate related rates. You hate this? I'm going to make this 1/2 see it a little better. Minus 1. Right, because it's velocity. All of this is velocity. And then I got this minus 1. Let's clean it up and see what happens. This is gone. All right? 4 times 8 is 32. I've got s minus t to the 1/2. This one's to the negative 1/2, so I'm going to throw it down here so you can see what happens. Oh. 32. Why is it crazy? You will get used to that. It is hard to see initially. You will start to get into that thought process. It's that thinking, yeah. You never know to go back and plug in. You'll start, the more we do like that, you'll start to see. Yes, that's what I found was acceleration. It's hard. That's always the hard part in math, for sure. Did you feel like the FRQs were straightforward, though? I feel like sometimes we practice harder ones in here, and then whenever you get on the test, you go, which I would much rather it be like that. I'd rather it be like that than flip-flop. On the FRQ yesterday? It's your first one, though. How many points did you get all together? I can't remember how many we had. How many we have? 18? How many did you get out of 18? I've given, yes, we're going to put those in our file. I've given full-on practice tests before, and I've had students who pass the AP exam not score more than 2 or 3 the first time they take it on their entire FRQ section. We're talking 54 points altogether, 6 questions, 9 points each, and they still came back. So don't, see, I think that's really good. I really do. You've only done this forever. You don't know what you're talking about. All right. How about the multiple choice on your homework? 62. Which of the following is equal to the second derivative of, did they give us one to use? Oh, it's up top. X squared minus xy plus y squared equals 1. So it wants to know the second derivative. It wants to know d squared y dx squared. So 2 times 2x minus derivative of the first times the second plus the first times derivative of the second. Make sure you have those parentheses in there. Plus 2y dy dx. Make sure you take the derivative of both sides, not just one side, so it equals 0. Did you do the one right here closest to us, Max? There's one on this side. It's been working, but the other one hasn't. Negative x dy dx plus 2y dy dx equals negative 2x plus y. So dy dx, and I'm skipping a couple steps here. I'm going to switch that around to that over 2y minus x. I haven't done the second derivative yet. Looking at the answers, and this is something I'll start stressing as we start doing multiple choice practice, I always look before I work forever, and I look at how the answers are formatted, because sometimes that will clue you in on how you need to do this. In other words, I know I'm taking the derivative of a fraction. Should I make it a negative exponent and do product rule, or should I leave it like this and do quotient? And judging by the way they have their answers written, I'm going to do quotient. See how that denominator has got, it's in parentheses with just an exponent on it? That's going to clue me in. I think it's going to be quotient. I think it'll be easier and save me some time if I do quotient here. So I'm going to do second derivative, and then I'm going to run through quotient. So derivative of the top, which would be dy dx minus 2 times the bottom, 2y minus x, minus the top, times derivative of the bottom, 2 dy dx minus 1, all over the bottom. Did I do it wrong? I bet you have. You're just starting to second guess yourself. Now. So now that's when I'm going to do that. It just say take the fine though. You know. But you know, if you look at this and you look at the way the answers are, you know this is not one of your answers, and you have to go, wait, what else can I do, right? Right? Because let me look at it. You got these. It doesn't look like any of these. Yes. Yes. That's right. That's right.
But honestly, last night I was like thinking I was just fine, and I worked my food.
You're talking about the CUDA sheet. CUDA sheet.
Whatever we did last night.
This is what your homework last night was doing for you. They were factoring out, like I've got that y minus 2x up top. You see it twice. They kind of factored that chunk out, put it in the front. I probably wouldn't do that, but if you want to. So you could say 2y minus, oh, never mind, they're not the same. You're right, they're not the same. Sorry. I got the, there's a glare, right? That's right, I can see. Don't blame me. I was thinking that these two were the same, and they're not. Okay. Well, y'all, you know what we have to do? Not yet. Let's stop and look at the answer choices right now. Oh, they're all cubed on the bottom of mine. I see what you're saying. Okay, but if you do that, it's going to change these values. Right, because essentially what you're doing is factoring those out of there to move to the bottom. So if you factor them out of there, you could do that, but then you'd have to make this 2y minus x, 2y minus x. And then this is gone, but it becomes 3 down here. Okay, I'm just going to go back and do this algebra 2 style because that makes the most sense to me. I'm the best with algebra 2, so I tend to do things that way. I'm going to have common denominators. 2y minus x is my common denominator. 2y minus x, and I'm going to combine up here. So I got y minus 2x minus 2 times 2y minus x, and all of this, and then I'll move that denominator down, times x minus y minus 2x times, I'm going to put this 2 up here with that guy, 2y minus 4x over, well, let me write it in here, 2y minus x, and up here, I'm going to say minus 2y, all over right? Well, yeah. All right, so let's see. This is going to be minus 4y plus 2x. So the 2x's cancel. I've got negative 3y minus y minus 2x times, it's really gross, 2y minus 4x. I think I'm doing way too much for this. No, that's cheating. 2y's cancel. Negative 3x over 2y minus x. It's looking better. I would have expected you, if this was a multiple choice, start and come back to it if you got time, because you would not want to get bogged down this long on anything on this. So let's take it. Let's do negative 3x times y minus 2x. Good thing. I'm going to multiply by the reciprocal at the bottom there, which I think is what Lainey was getting to. I'm going to times this by 1 over 2y minus x cubed squared. I'm getting ahead of myself. I'm almost there now. I'm almost there though. Now I got to get a common denominator again. 2y minus x. So I get negative 6y squared plus 3xy plus 3y plus 2x over 2y minus x. That's not! I'll do that one again later. I'm not spending 20 minutes in here on that question. Yes. I'm not spending another 20. I'll work it out and I'll send you the solution. Bye-bye. I'll send you how I do it. Probably made a stupid mistake earlier. 17 on the. Can you tell me the problem? What do you have to do? The second derivative? All right. Yeah. All right, so 2x equals negative 10y dy dx. Derivative of 4 is just 0. I'm going to solve this. 17. Hot July. Nobody's singing with me. All right, second derivative. No. You got to take the second derivative first. Always take the second derivative before you start plugging in. You'll only plug in when you take the second derivative. You can't use the first derivative you can't plug the first derivative into itself. You plug the first derivative into the second derivative. Okay, so here, like derivative of the top is negative 1 times the bottom. I'm A-okay there. Minus the top times derivative of the bottom, 5 dy dx. Here's where I hit a problem, right? Because I can't have a dy dx here and a second derivative on the left side because I got to get one of them by themselves. So now, right, now I would plug in. Now I would take this and replace that dy dx. Wrong? I'm going to change this to plus x. This one's nice because stuff starts happening here. Yeah, why not? I'm not done yet. I got to find a common denominator up top to combine those. Negative 5y squared minus x squared over y. And I'm going to go ahead and multiply by the reciprocal of the bottom. I multiplied the top and the bottom by y. That was the bottom squared, yeah. Not yet. Where? No, because that one doesn't have a 5 to give. You're talking about what? No, because I canceled this 5 out here. You could have taken this one, and left a 5 there, but then this one would still be here. Because it's in the bottom. The green y. I needed to combine this numerator here, so I had negative 5y minus x squared over y, so I gave it a common denominator of y. And then I multiplied the reciprocal of the bottom. That's exactly right. Because I had a fraction and a fraction. So now I got negative 5y squared minus x squared over 25y cubed. The final answer. That's as far as I'll see taking it. Y'all keep saying, what quiz practice are y'all talking about? No, you had, yeah, the evens on the sheet. You did evens tonight. Besides one word problem. These are harder, I think, than what's on your quiz. Give me the problem. What's that say? Okay. You want me to do quotient or quotient? Y'all love quotient. I hate quotient. Okay, that's all right. Derivative of the top. 3 times x squared plus 2, and I have to chain it. Times the bottom. Minus the top. Times derivative of the bottom. 2 times 5x cubed plus 4. And I have to chain it all over the bottom squared. If I square a square, what happens? The exponents multiply. That's exactly right. The first thing that I see before I even do anything else, these 5x cubed plus 4s, there's one here, I mean, there's 2 here, there's 1 in this piece, and there's 4 down here. I'm just going to take one of these out. That's the very first thing I see. Yeah. Well, this one only had 1 to give, so I can only take 1 away from it. So it's just a 1 now. Yeah. No, just took out 1. So it left 1 here. There was 2. I took 1 away, it left 1. So now I've got 6x. I've got x squared plus 2, and I've got that 1, 5x cubed plus 4. Minus 30x squared, x squared plus 2 cubed. That's it, right? Over 5x cubed plus 4 cubed. I would probably stop right there. Well, they kept going on that one? Okay, so the only way you can simplify completely on this is if you multiplied out up top at this point, because there's not really anything. I mean, I could factor out an x squared plus 2. Yeah. Oh, you're right. Shut up, Joyce. Where are y'all looking? Oh, I see it. Okay, I see it, y'all. Great day, Joyce. You're making me blush. I'm embarrassed. Making me frazzled. Yeah. But what I was saying on this is, you'll stop laughing. Because I wanted to cry and I was trying not to. No, I'm just kidding. I'm not gonna cry. Save my tears for what? My pillow? I could multiply out that top and then bring it back down, but I don't see any point in that. What'd you say? Which one did you say? Somebody said 1.